Hello, today we'll be drawing some functions, and this is going to be the first example. Here we go. This is f, and it's always good to take a few seconds to recognize the kind of function you've got. And this is a rational one because we've got division between two polynomials, x minus 3 and x plus 2. First step in order to draw f will be the domain, analyzing where f is defined. Rational functions, as you all know, have problems when the denominator is 0, because any kind of number over 0 is not defined. So equal the denominator to 0, solve it, we will be obtaining in this case just one value, x equal minus 2. The domain from minus infinity to minus 2, from minus 2 to plus infinity. Remember, this is not really a u, it's the union symbol. Second step, asymptotes. And we will first of all analyze the vertical ones, what happens at x equal minus 2, because in case of f having any kind of vertical asymptote, that one will be at x equal minus 2, because that's where f have kind of gap, okay? So the limit x approaching minus 2, replace minus 2 in the function, and that's minus 5 over 0. And that's why we've got here plus minus infinity. This is the solution. So x equal minus 2 is the equation of the vertical line. If the solution was a number, it meant we didn't have any kind of vertical asymptote. But this is not the case. It's just plus minus infinity. So, okay, we've got the vertical asymptote. At this point, you should be drawing a sketch of the graph. Draw the x-axis, y-axis, and locate the x equal minus 2 asymptote. Horizontal asymptotes. Those are x approaching plus infinity and minus infinity. So let's see what happens in the corners. I mean, on the right side of the graph and on the left side of the graph. I started myself analyzing the right side, x approaching plus infinity. And in this kind of limits, we're taking the leading terms in the numerator and the denominator. Both are, in this case, x. And solution 1. So y equals 1 is the equation of the horizontal asymptote on the right side. If the solution here was infinity or minus infinity instead of a number, it meant we didn't have any horizontal asymptote. But it's just a number, so yeah, we've got it. And draw. Okay, I draw it here. In the minus infinity, just the same. So again, we've got the horizontal asymptote on the left side. Third step will be intersection point with the axis, x-axis and y-axis. Okay, intersection point with the y-axis. So replace x equals 0 in the function, and we're obtaining minus 3 over 0. So 0 minus 3 over 0, minus 3 over 2 is an intersection point with the axis, y1. Okay, x intersection points, x-axis intersection points. So equal the function to 0, y equals 0. So instead of f of x, we're writing 0 here. And these kind of expressions will be 0 as long as the numerator is 0, because 0 over any number will always be 0, except from 0 over 0. You know that's an indeterminate form. But, well, you will need to equal the numerator, in this case to 0. So we are obtaining x equals 3. 3, 0 is the other intersection point with the axis. And go back to the graph, locate the points. Here we've got. And fourth step. This is a really important one. Increase and decrease intervals. We'll be calculating the derivative here. And okay, this is a division, so we needed the division formula. I'm just calculating, simplify the numerator, and here we've got the solution. This is the derivative of the f. I equals to 0, and whenever this is 0, that's where we've got critical points. The thing is that this will never be 0. These kind of expressions, I told you, are 0 when the numerator is 0. But this is 5, and 5 will never be 0, because it's just a constant. So there's no any critical point in this case. You still make the line, the x-axis line, and locate the value where the vertical asymptote was, x equal -2. So that's why I made this kind of line here and locating -2. Choose two random values on the left and on the right side. I choose myself -3 and 0. So replace -3 in the derivative. Realize here I am writing f prime and not f. So f prime of -3 is 5. I'm replacing in the derivative and it's 5. That's bigger than 0. That's positive. So I've got here an arrow going up. The function is increasing in this case. On the left side of this vertical asymptote, the function is going up. When you replace 0 in the derivative over here, it happens just the same thing. The value you obtain is greater than 0, so arrow going up. So it seems that the function is all the time increasing. That's why increase interval is just the same to the domain. From -infinity to -2 is increasing, and from -2 to +infinity is, again increasing. Decreasing interval, the null set. Go back to the graph, and at this point you should be drawing really the graph itself, f. So start from the left side, and it should be this way, going up, and again going up on the right side. So that's it. I mean, this is our function, and that's everything.